in the case of astronomy, and also guide you on how to do the installation from PIP or COMDA, depending on your choice. And then we'll also talk about how to use this concept in astronomy, or even how to write your own codes, and how to use, you can also use it to do use these tools, whether it is the one specifically designed for astronomy or the ones not specifically designed for astronomy, but you can still use it to solve some of the astronomy problems or analysis. So I believe you all have received this email from Label about the course roadmap and schedules. So please, let me just go over it again. This is week 0, or we called it week 0 because it's more like this is the week where everybody will get familiarized with the tools and learn to the installations. And if they have any problems, they will share it on Slack and notify us so that we can guide. Please, it's an open community. The reason why we have you on Slack is for all of you to share your problems, and please look out for other people who share problems. If you think you have solved that problem, please kindly help out. So the week 1 is the orientation week. Sorry, week 0 is the orientation week, which is today. Next week, which is the 14th of May, we're going to start with the introduction to Python. And in the 3rd week, which is 2 weeks from now, we will introduce you to data analysis. So the week 1 is just going to be to introduce Python, basic Python programming, some of the key things that you need to know. And then you go into data analysis. Then the upper week will be the week 3. We're going to focus on data visualization or representation. So what is data visualization? Like I stated earlier, majority of the time you crunch data, you analyze data, but remember, it's not just you doing this. Sometimes you need to share whatever thing you've done with the public. It could be your workplace. It could be a presentation in class. Maybe you have a presentation. It could be your project. It could be a research, maybe in a publication. So most times you need to make sure you're able to get your data in a way that you can represent them so that people can see it and understand what is going on. So that is the visualization. And this sometimes also come up with a way of managing colors to make sure that your visualizations also come out distinctively, and making it interesting for people to want to look at it and maybe ask questions and understand what you're dealing with. So in the 4th week, we'll be dealing with data sources in astronomy, because remember, our objective is to get you through programming and also see how you can use those skills to perform tasks in astronomy. We're going to introduce you to data astronomy sources. We have different, like I said before, in astronomy, telescopes collect data. People also do simulations. This data are stored somewhere. And we'll introduce you to some of the data archives and where you can collect data, where you can perform data analytics, and also how to handle this data in Python. Key thing, Python, using Python to collect data from data archives, do data cleaning if you want to do it, perform data analysis and visualization, and also answer any astronomical problem that you think will be of useful to you. Then moving forward, in the 5th week, we will look at time series analysis. Now, the time series analysis is just one of the use cases in astronomy where we are going to introduce you into specific science cases or science concepts where you will have to play around with some real data sets and perform analysis that is worthwhile, an analysis that is presentable, that is explainable, that it relates to core science. So what is time series analysis? Time series is mostly times observations or data collected over time, where you record the time stamp and also the information that you've collected. A good number of them. So those who are not familiar with astronomy yet, a good example is weather data. If you wake up every day, you go to your app, to your weather app, you see data. Maybe you see, oh, it's going to rain today, or it's going to be sunny today, it's going to be cloudy. You see the time, you see the data alongside the time. So that is an example of a time series data. Another example is for those who are familiar with the financial market. Maybe you are looking at a stock, or you are looking at a stock, or you're looking at a currency. You can go to your country, go to maybe Google, research your currency and the exchange to dollar. You will see over time, maybe today, yesterday, tomorrow. You see today's date, you see the timing, you see a graph like the time, and you see how the price changes. So that is time series analysis. So in astronomy, we also have that kind of case where we have observations that are done over time with time series analysis. Majority of the time, we call this analysis light curve. Yeah. So we'll touch that in week 5, and then in week 6, starting from the 18th of June, we'll go into basics of machine learning and how to apply it in astronomy. So I believe that is what caught some of you's attention in this course, is because of the machine learning part of it. So we intend to just go through the basics of machine learning, navigate through the important aspects of machine learning, why it is relevant today. I'm sure many of you know why it is relevant. Today, we are hearing about the word AI. Everybody is talking about AI, but it's also it is built out of machine learning. So machine learning is a type of artificial intelligence. And the idea is to build softwares that can do predictive analytics. So instead of you sitting down and always doing the analytics yourself, you should be able to write a model or write an algorithm or model that can be able to do this prediction over time. So we introduced it to the concept of machine learning. So it's going to take 2 weeks because we're going to focus on 2 aspects of machine learning, the regression part and the classification part. This is not going to be high level. We do, because the time frame for this course is not enough to teach machine learning in a very broad way. So we're going to focus on the beginner part of it, and with that, we hope you can be able to proceed from there to learn more about machine learning at your own convenience time. And then in week 8, we will do a bit of the capstone project. So this is very, very important. Remember, whenever you do a course, you do what? A course in the university, you write tests, you do assignments, you write exam. And if you pass the exam, that is what justifies that you did take this course and understand the course. In our own case, this is a hands-on program. And we believe we all have an interest. And that interest is what brought you into signing up for this course in the first place. So the capstone project is where we intend to allow you to show us the skills of what you have learned over the last 8 weeks, the skill sets that you have learned, how you have been able to apply it into your own problem, because you need to define your own problem. You pick up your own problem, you tell us what you think or how you're able to solve this problem with the skills that you have learned so far. So this is not going to be so in-depth, but we're going to provide guidelines on how you can go about this over time. So what you need to do is that you need to pay attention for every week. The results that is being shared to you, you make sure that based on the problem that you have defined for yourself, in these resources, what particular information there is useful for you to perform the analysis or visualization or scientific problem that you think you want to address with those skills. So that is what week 8 is going to be about. It's going to be about us learning from you, learning from how you have been able to utilize the course. Okay, going forward, I think I've talked about the roadmap. Let's talk about what is expected from you generally. This course, like we stated earlier, is going to be an online, purely virtual, no hybrid, no physical spaces. It's purely virtual. What it means is that you need an access to a working computer. In your computer, you should at least have any of the programming operating systems, such as Mac, it could be Windows, it could be Linux, depending on the one that you have or that's available to you. And again, you must have access to an internet. That is very, very key, because we will always have meetups every week. And in those meetups online, where we'll go through a snapshot of your resources for the week and provide some basic explanations, and maybe take time to go through question and answer section. So we need you to be available, and in that case, you need access to internet. Then another important thing is to also make sure you have a software installed. because this is going to be a hands-on section. So therefore, we require that you get Python installed, and we recommend Anaconda software. But it's not necessarily, that is not the only option. If you have started with Python before and you haven't know how to navigate the Python installation like other Python frameworks, then good and fine, you can use that. But as a beginner, we recommend you start with Anaconda because it saves you from the hurdles of doing the installation that can be very technical sometimes, or installing of packages. Most of the packages that we need are already pre-installed with Anaconda. And then for more details on how to go about this, we have shared you a BRICS link, which to an extent is available here. I think many of you should have access to this very BRICS link now. Just shared, so I remember I recall vividly earlier this week or so. So please, we'll get to the question and answer section in case if there are any questions on maybe things that challenges any of you have been going through. So please take your time to read through this. All right. Okay. So one more thing is for those who haven't joined Slack, we have provisioned a Slack link since a week ago for you to join the Slack, because Slack is the workplace that I think majority of you will be able to fit in. We understand people are coming from different parts of the world. I'm not sure if Slack is working in every country, but I believe this will be able to, with this, we'll be able to serve the majority of the people. So a Slack link, you can check your email if you haven't joined. Label have sent out the link multiple times. Please kindly join the Slack link and join the group workspace there, and you'll be able to have access to the resources that will be shared and any other information that is required from you or relevant to you. So let me just talk about the installation process. This is just for the basis of those, for maybe those who are having challenges or those who have not attempted to do so in the first place. The first thing, like we recommended earlier, is to use Anaconda. Anaconda is a software. It's a Python distribution that comes with majority of the data science tools or frameworks or packages. So what it means is it comes with a base Python. It also comes with the dependencies for data science or even machine learning tools. So it is bundled into one. And here, don't worry, this slide will be shared with you in case, but this link have also been shared in the resource BRICS orientation link for you to go through. So here, if you click this link, this takes you to Anaconda, and then you should have something like this. Then depending on your operating system, like I stated earlier, this link will take you to Anaconda website. Depending on your operating system, kindly install the graphical installer for your operating system. For those who use Windows, this is your link here. I recommend you download this. For those who use Mac, depending on your chip, if you're using an Apple Silicon or you're using Intel chip, you can see you have two options that suits you. You have one for the graphical installer, and then you have the bash one that you can install through the command line for those who. But please, if you are not familiar with command, how to use command prompt or how to use terminal, please just stick with the graphical installer. Unfortunately for Windows, you only have the graphical installer. There is no command line installation. And then for those who use Linux, it can be a bit technical, but I believe if you use Linux, you definitely will be familiar with how to run things on the terminal. And in that case, you will install the 64-bit installer for Linux. This works for Ubuntu, Fedora, any of the Linux distros. So this is just it. So I can come here and try just to give you. This is my own. So this is for my own case. This is Apple Silicon. This is the graphical installer, and then if I click it, it should be able to take me through an installation. I can see it's downloading here. I think I tested it some time ago, but let's see if it downloads. I just want to give you a clue on how you can proceed with this. But while we wait for it to download, I can also maybe go to the slide and talk about other things here. So like I said, you select the installation installer for your operating system, Windows, Mac OS, or Linux. Don't try getting the one that is not for your operating system. Otherwise, it is not going to install. Then for the installation guidelines, here is the installation guidelines. We have these installations for, you can see they have one for Windows. They even have a YouTube video for it. You can go through it to do the installation yourself. And oh, it does look like they also have for command. They do have for command prompt on how to install with the command prompt, but I wouldn't recommend that. Just stick with. It's simple. Just download, click on it. It opens. You follow the prompts that shows up in the GUI, and then you will have it installed on your PC. So they do have for Windows installation. There's one for Mac and Linux. You can watch this video or you can follow these instructions here on how to install for your operating system. All right. I've already, like I mentioned earlier, these informations have been provided in the pre-course link, which you already have, which I shared earlier here. If there's anything that is confusing you, please share it in the pre-course orientation channel. Yes, and then I think that's all. So another thing is if you have any problem, please do share your problems in the pre-course orientation channel. So what is the pre-course orientation Slack channel? Let me go over to Slack. I think before we do that, let's see if this guy has installed. I've downloaded, sorry. Yes, it's done downloading. So let's try it. So, okay. Yeah, for some of you who are looking, I'm sure you're looking at my screen. So, yeah, so it pops up and then you go through this. This is just nothing here, just introduction. All you just have to do is continue. In the README, you just have to do is continue. So you can see it tells you that this is yeah, it does tell you that this is a distribution of Anaconda 3, though it didn't specifically mention the Python version. I think this is Python 3.12. But then it goes ahead to tell you all the packages that is packed in this distribution. You can see all of them here. You can go through it. You can see there are a lot of packages. So what it means is that all of these packages are already come with this distribution. So you don't have to worry yourself about reinstalling them again. Let's see, you will see things like we have SciPy, we have scikit-learn. We have scikit-learn, we have SciPy, which are some of the things you'll be using for this course. We have Seaborn. We should have Matplotlib for graphical, for making graphs. So you can see things like Pandas for data analytics. You can see things like NumPy for array data analytics. You can see things like Matplotlib. You can see it here. And then just like that. So it comes with a lot of packages, so you don't have to worry about installing them. So I'm satisfied with this. I'll click continue. And then it shows me the license. All I need to do is just continue. You just continue with continue prompt, then agree. And then install for all users of this computer. Yeah, please always stick with the first choice. And it tells you the amount of memory. So that's one more thing. In your own case, you would make sure you have enough memory space on your PC too, so that you can be able to install it. Otherwise, if there's not enough memory, it won't be able to install. So it asks for my password. Don't know why this is skimming now. So I've given it authorization to proceed and install on my PC. So you can see the installation is going on. Okay, so it tells me that the path already exists because I've installed it before. And it's just say continue to the cloud. I'm not sure, but then we just continue. Yeah, the reason why it's the installation field is because they already have the software installed. So there's no need for installation, which is a configuration I did with my PC. So that's it. So I'll close it. I'll move it to bin because I don't need the software to occupy space. So that's it on this. And let me see, just to show you one more thing on Anaconda. So if you successfully install the graphical user interface, if you go to your home, that is where all of the apps, depending on the PC that you're using, you should be able, this is for Windows and Mac users. This is for Windows and Mac users. You should be able to find Anaconda Navigator here. You search for it on Windows or you search for it on Mac, and if you click it, it is going to open a user interface for you where you can start your Jupyter notebook, because that is the resource we are going to be using in this course. So we have this, but you don't need to sign in for any coding help. If you want, it's an option, you can do that. You can sign in if you want to play around the Anaconda ecosystem. You can create an account with them. So here you have a lot of tools in the Navigator GUI. Many of them are designed for purposes, for data analytics, for writing, for maybe better visualization and the rest of them, or some also support software that are pre-installed. For example, this is Python, is a common IDE, Python IDE for an IDE, common IDE for programming, for Python majorly. It is not installed on this PC. We also have VS Code. Some of you might be familiar with VS Code. It is installed on this PC, so you can see it here. I can launch it. So we have notebook, but two things which I would recommend is, this is the two things you can use depending on the one that you like. They are all Jupyter notebooks, but the GUI is quite different. So we mentioned you can use Jupyter Notebook or you can use Jupyter Lab. So I can click Jupyter Notebook now, and then it's going to do something, and then it's going to start running. Just hold on, let's see. You can see it starts, it creates a server. What it does is that if you immediately you launch the Jupyter Notebook, it creates a server for you. And then with that server, you can proceed to, it generates a link, a localhost link here that you can use that automatically opens on your browser, your default browser or any browser that is open at the time. So with that, you can go through, this is the folders in my home directory. So in that case, you can go through any of the folders and pick anything that you want, and something like that. Let's see, this is a case where I have, say one of the notebooks that is in the GitHub that will be shared with you. I think some of you may already have it. So in this case, you can see I have opened this notebook here. And with this, I can start running through the resource. So this is how Jupyter Notebook looks like for those who are not familiar with Jupyter Notebook. Sorry, let me close this window. And then with this, you can, so this notebook, these resources have been prepared in such a way that you have a text where you can read in Markdown, and then you have a case where you can run the cells. So this is an example where the topic is variables and data types. And you proceed to read this, and then you can also write your own code. Like this is already running. So server, when the server starts, so you can see I can run this. So to run this, you just have to press Shift Enter, and then it runs for you. So that's by the way. Well, this is not I just wanted to show you how to start the Jupyter Notebook, or how to, so you can see this is done running. It prints the alpha centrally for you. And then I can close this now to, I think I can close this to demonstrate how to, sorry, I need to get this off. You can close this so back to, Navigator. I like I said, I just did for notebook. If you prefer the Jupyter Lab, let's open Jupyter Lab so you can see the interface and how it looks like. Sometimes I do prefer the Jupyter Lab because I can just stay in one browser without having to go into multiple browsers when running notebook. So you can see the interface is quite different. Instead of having your home folders in the center, it brings it on the left, and then on the left you can easily proceed, and then you can navigate through without having, and then when you click, this is the same file we opened earlier, and you can just stay in the same place. It opens, and then it just keeps opening the tabs just in one browser without having to open in multiple tabs. So it's just the same thing. You run things, it runs, and you're good to go. So this is just a demonstration of how to install Anaconda and open up the navigator and then proceed to do the installation. And navigator and proceed to start a Jupyter, launch a Jupyter notebook. So that's by the way. Please, if you have any questions, kindly use the Slack channel, which we have provided earlier. I've mentioned to you earlier. So let's now go to the Slack. Can close this. Good. So let's come to Slack. So this is us. I believe many of you are here. And for those who haven't joined, please kindly join the Slack channel. This is where all of the resources will be shared with you. Then let me emphasize something here. For each week, we are going to create a channel for that week and share the resources there. So this week is our orientation week. If you come here, you will see this is the pre-course orientation week. So after this call or after this section, we'll share resources, the resources that this slide using for this presentation and any resources that we think will be relevant for you this week. And please, if you have any issues with regards to installation, please kindly ask the question here. Join this channel in case you haven't joined. There's a way to join channel. You just come to click channels. You is it good? It's supposed to be like browse channels. Yeah, so you come to manage. So the first thing you do is you come to channels. So some of you who haven't joined or haven't seen it, you click channels. Then it brings up the manage. And then in the manage card, you'll be able to see a drop down that shows you mark as read or browse channels. So in the browse channels, you'll be able to see all the available channels. So these channels, these are the current channels we have now. So this is, you can see I've joined the pre-course orientation. Please kindly join the pre-course orientation and share all of the problems that you have there. Please, you only have 11 members now. Please, all of you should join it. If you have any problem, please ask questions there. Even if you don't have problems, please join because the resources will be shared in that pre-course orientation channel. And then one more thing is, in case someone has a problem and they share a problem there, please, if you think you know the answer, kindly assist them by responding. I'm going to come back to that later on how to navigate responding to people on Slack when people ask questions. So let's go back to our slide. All right, so we're done with this. So the learning resource. So this is a hands-on program, and we have prepared resources for you to consume. And these resources are strictly for learning purposes. It is best recommended that you try your hands, you get your hands dirty, and ask questions where necessary. So, but these resources are available on GitHub. We have a GitHub repo, which some of you, if you're familiar with GitHub, already contains, you may have seen the resource anyway. So let's say, for example, I click this link, it takes me exactly to the GitHub repo. So we called it BRICS Astro. So please pay attention to this. This is a GitHub repo. For those who are familiar with GitHub, you might understand the other things there, but we will be sharing our resources based on weeks. So this is the pre-course link that was sent out to you. It's a markdown file. And then this is the week one. So in the week one, you will have resources on different topics that we have. They have been numbered from 1 to 9. These are just things that your code will generate in the course of running it yourself. So what you need to do is, the way these things are numbered, you go through the first one. You have to consume the first one. When you're done with it, you could proceed to the second one. So you just continue like that. The first one is nothing other than just getting started, just telling you, oh, you have this. So what is this? What is that? So what is Google Jupyter Notebook and Google Colab and all that. So in this Jupyter Notebook, as you can see, we have a link here. Each link comes with notebook comes with open in Colab. So why are we doing this? We are provisioning a link on this Jupyter Notebook such that in case if you are not able, if you have PC problems or your hardware is difficult, maybe to install the Python distribution, or you can't figure out how to do so, to save yourself time, you can also make use of the Jupyter Google Colab. So Google Colab is a Jupyter Notebook provisioned by Google. It runs on Google Cloud. So all you need is a Google account. So if you have a Google account, a Gmail account, you just need to click the link and it pops up. It takes you to Google Colab. I'm going to do a demonstration now for you to see. So if you click the link, okay, just a moment. So I've clicked the link, and then here we have this opened in Google Colab. So with Google Colab, you can still read the same information. You can run the code. So this is running on Google Cloud. You can run the cells. You can read it. You can run the cells. It's going to ask you, do you trust this? Do you trust the author? And blah, blah, blah. You just say run anyway. And then it's going to provision the resources for you. It's going to connect you to Google Cloud endpoints. You can see it's connected here. It gives you a reasonable RAM and a disk for you to run. These are basic tasks. So it's not going to consume a lot of memory. So you can run it all through anytime. So with this, you can run the same cells. It runs. You can read, you can run. But let me advise you, if you are running your Jupyter notebook on Anaconda or locally on your PC, if you make adjustments on the notebook, you can also make adjustments yourself. It will stay on your notebook. But if you do that on Google Colab, immediately you close this, it is not going to stay, because remember, this is running on the cloud. It is not running on your system, on your laptop. So what I'm going to recommend is, if you find these things interesting and you want to try out, like for example, I can define a star name as Alpha Centauri this way. Say I want to define another star name. I can copy this and maybe change it. I can change this to say, something like AR score. And then if I do this, I have changed this, I've made these changes. I will run this, and then if I print, it prints out AR score for me. But because we are running this on Google Colab, when you close this, it is not going to save automatically because it is not running on your PC. But what you can do is to simply come up here in the menu, you click File, and then you go to Download, and then you download as .ipynb. So in this case, it is going to download this notebook for you. We click download.ipynb. It is going to download this as a Jupyter notebook for you that you can save on your PC. So please have this at the back of your mind while you're doing this. So moving away from that, let's close this. And yes, I can leave and come back to the... So for you to start this, you have to be, you can just open this on your browser, this GitHub repo on your browser. So for every week, this is week 1 resources. For every week, you'll have week 2. So just it's going to be structured like that till the end of the course. So have it at the back of your mind. All right, let's go back to the slide. So like I said earlier, pre-course information is available there. Notebooks are available for you to consume. And these resources, again, will be shared for you on Slack. For those who are not familiar with GitHub, we are going to share the week 1 resources in a folder and put it in the Slack for you to consume. All right. Then this is just a clue for those who are, those who are curious and maybe you're not familiar with Git or GitHub and you want to learn. Remember, this is a pre-course orientation week, so you can try get your hands dirty. You want to get your hands dirty. We recommend checking out this tutorial. I think it is easy. It talks about Git and GitHub tutorial, how to do version control. But this is not part of this course. This is you doing some exercise and trying to learn about what is Git and what is GitHub and how to even play around it and how to install it on your PC. So I do recommend this. Yeah, but it is not. It is optional. It is not compulsory. So this link will be shared. When you get this, you can click there and then access the information there. So that's by the way. So now, code of conduct. We understand that we are all coming from diverse background, different countries, different race, or scientific background. Some are students, some are working, some are researchers. So we want us to respect each other and be kind to each other in the community. Avoid any form of harassment, bullying, or discrimination. respect people and also cite people's work. If somebody may have written a code, maybe did something, you need to also acknowledge them and also bring your own perspective. But please learn to discuss respectfully with everybody. When you're asking questions or discussing about any topic, please do that respectfully. And if there are violations, please kindly report to us. We'll make that information clearer on how to go about that. And also, you need to understand that this information applies to both here during presentation and offline, online in the Slack channel. So if you have any issues, please, you can reach out to Label through privately through a DM, or you can reach out to me. All right, so going forward, this is just a clue. We want you to succeed, and it's important that you succeed, because that is the objective of this course. What we expect from you, or how we think you can succeed, is that you need to engage with this content seriously. Please consume the resources, read. When you read them, practice them. The notebook is very, very user-friendly, so you can just create a new cell. If you create a new cell, you can play around with anything that is in your head, play around it and see whether you're going to still get the same results, or whether whether you're going to have a problem. But if you encounter any problem, please ask questions in the Slack channel for that week. Ask questions. Don't be scared. Don't feel shy asking your question. Remember, nobody knows better than each other. We believe everybody here are equal. So ask questions. No question is a stupid question. Just make sure you present it in a way that people can understand. So on the other hand, we'll also recommend that you, like I need to emphasize, that get your hands dirty. And then number two, beyond the resources that we are providing to you, consume them. But beyond it, also check out online. There's Google there for you to help. You can do a Google search or any of your favorite search engine. You can use that to ask questions. Some of you, I believe, also use the new AI, generative AI platforms out there like Jupyter or Gemini. Please, for a particular concept, you can also use it to, prompt it to give you meaningful answers, or in a way that you can understand. This is how to learn. So every week we'll be having a lecture online, and in that lecture, an instructor is going to provide concepts, try and explain the concept for each of the topic, and you have the videos will be shared with you at the end of the lecture. Or that is for those who did not attend, who could not attend the meeting online. And at the end of the day, please, it is relevant that as you are learning this, the things that matter to you, some of the things that you think are relevant, you take your time and document them somewhere, because it will help you in building your portfolio project. So a portfolio project is just you addressing one problem. It can be something that is very basic. It can be one data that you have for a long time that you don't know how to handle. It can be a tabular data. It can be an image that you don't know how to handle. It may not even be astronomy. And we want to see you, based on the skills you've learned from this course, take that data, analyze it, explain the concept, and perform some statistical analysis, do some data cleaning, and at the end of the day, provide us with some beautiful visualization, maybe graphs that we can easily look at and understand what your problem is all about and the insight you have generated from it. So that is on one hand. And I think that's it. The links that some of the things we've talked about, the links are here in case if you don't have time to go through this because maybe you have consumed this before. All of these links are available for you to access to. So please, whenever you get access to this, please kindly just go to the links and click it. They'll open up for you to consume. And I think we're done with this now. So the floor is open for question and answer section. Label, are there questions on the Slack channel? Okay, can you read out the questions? I'm not seeing them.
Good morning, everyone. Oh, sorry, go for it.
So
Thank
the
you.
question is AstroQuery the only way to access data from NASA satellites? No, I don't think so. NASA runs a lot of projects, and AstroQuery is just one of those tools that you can use to access data if the data is provisioned to virtual observatory. But NASA do have, I think it's called HASAC, because they do run a lot of high energy observations. There's, if you go to their website, I think just HASAC, you'll be able to see information, the data archives there, different kind of satellites, whether it is infrared, whether it is mostly X-ray, most of your space satellites, you can see data there. Some of them also do have Python, their own Python frameworks that you can use to access it. Some of them also have links to like documentation, maybe on how to do data analytics with their data. I recently learned last year they do have a cloud service, but I think it's based on institution. I think it is on institutional access or student access for you to access it. But that's all for now. Yeah. Any other question?
Good morning. Well, thank you. Is it possible to get your presentation in the Slack group?
Yeah, I mentioned it before. This presentation will be shared
Okay.
by the end of this. So it's like I said at the last in the section before this one. There's a link there which said this will be shared. Yes.
Okay. Thank you.
Okay.
Sure.
I'm
Good
looking at
morning,
this.
everyone.
Hi. Sorry. Please. Let's put our questions in the chat. Apologies. Let's go through. I can proceed. I'm seeing them now. And also, some of them have been answered to, like the one from Madhol Teraja about YouTube playlist recordings. I think today's is not being shared on YouTube, but Sally has responded to that. Yeah. So let me see. Okay. Jatin said, can anyone suggest good resource to begin learning about statistical methods and their use in big data analytics? Well, there are a number of resources available depending on the kind of thing you're looking for. You need to be specific because statistical analysis is also very huge. But I think what I will recommend for you is to do a quick Google search. You will see tutorials online. It also, because you say learning about statistical methods and they're using big data. There's also a YouTube channel called 3Blue1 Brown. I think they do a lot of that. They do a lot of explanations, and they are very good in terms of explaining the statistical methods, the things around statistical analysis and hypothesis testing. So you can check that out. But for coding, of course, there are 1,001 blogs that I've written about different statistical analysis, or even how to analyze data with pandas, SciPy, but it all depends on the area of statistics that you're interested in. I would suggest you mention, you state the methods in Google search, and you will see just the first page will give you a handful of information. Okay, somebody is saying, can I use Spider Anaconda? Yes, of course. If you know, you can also open that. It's also its own IDE. So please go through that if you're familiar with it. Like I said, this is an learning exercise for you. If any of those things, applications in the Anaconda Navigator that you feel like, please click it, open it, look at the interface, read more about it, because they also have a lot of documentations and tutorials online on how to use those tools. With that, you can find something that is convenient for you to go through. Okay, I don't know if there's any other question I'm missing out on. Okay. Okay, so okay, maybe we can go back to those who want to ask questions online. So I think we've addressed the questions in the chats. Not seen any. Please, for those who still want to ask questions, you can raise up your hand and we can call you. Okay, Jatin, you can unmute yourself and speak.
Sir, the project we have to do at the end, so
we have to do it in group or alone is fine?
Sorry, I can't hear you.
The project we are going to do at the end of the last week, is it do we have to do it alone or in group?
Okay, I'm not sure if the group team can work because of the different time zones. So we want you to do something on your own. We want you to do it individually. Yeah, because it's not so high level. So just pick a problem and use the same things you're going to learn. You can even go out of the resources we're going to share with you to see, because again, one thing you need to understand in programming is that for you to demonstrate that you know anything about programming, you need to show, oh, this is what I've done. So you can also write this code and you can keep them somewhere, or you can even put it on GitHub to share to people and say, hey, I was able to come up with this analysis and here is it. All right, Mehu.
Okay, sir. Thank you.
I just wanted to ask, how are we supposed to make the portfolios of our projects? Is it done in GitHub or is it done in something elsewhere, somewhere elsewhere?
Can you come again?
How are we supposed to make the portfolios of the projects that we're done? Is it supposed to be stored in GitHub or is it done somewhere else?
It's going to be in a Jupyter notebook, and then you share it with us. But we can also advise you that you put it on your GitHub repo.
Thank you.
Yeah. All right, Satya.
Yes, actually, while I was installing the Anaconda program, I selected to install only for me and not for all other users. Will that cause any problems in the future?
No, so long as you're able to start the Anaconda, I think there's no problem. Again, if it doesn't work, you can reinstall it again, so long as you still have the software on your PC and install for all
Thank you,
users.
sir.
Cool. Lindo. Lindo Kule.
Good day, sir.
All right.
Good day, sir.
Proceed.
I wanted to know if we're going to be assigned tutors, and will there be consultation sessions? Will we receive certificates after completing the course, and how valuable are these certificates? Are you able to get an astronomy job with this type of qualification? Thank you.
All right. Thank you very much. That's a good question. So starting with the assigned tutors. Unfortunately, the number of participants we have, it's so many that we can assign mentors to everyone. So, but that is why we decided to work in a community whereby if you have any problem, you share it, and we'll always keep our eyes on the Slack channel for any problem that you have. Just share it, and then we'll be able to go through. Someone will respond to you. And also, remember, you can also ask other people's questions. You can see even in the chat right now, some people are asking questions and others are helping in answering them. So don't be shy to ask any question. And then again, on the certificate thing, how relevant are these skills for a certificate? Yes. If you really want to get a certificate, then that is where you need to complete a capstone project. You must, because we want to see that you have demonstrated capacity over the 8 weeks that the program has been running. So we want to see that you're able to define a problem and then solve it using Python. It can be very basic, but we'll share more information about this in the coming weeks. Yeah, but wanted to mention it today. Please, let me emphasize this again. Getting a certificate will be dependent on you providing a capstone project. Yeah. And also for the job thing, well, of course, this now depends on what you do in your capstone project. If you want to, if maybe astronomy job, then I believe if you probably say, oh, you want an astronomy job, maybe a researcher, or you want to work in an observatory, a lecturer, then what it means is that you must pick one problem where you think you have domain knowledge. What I mean by domain, at least you have information to a certain level, maybe stellar astrophysics, maybe high energy astrophysics, maybe radio astronomy, maybe anything you pick out one data, pick out one problem, there one scientific problem, you define the use case and collect data, do analysis. With that, let's say you apply for a job, you can add that information with a GitHub repo showing that this is what you have done in the past in your own capacity as part of the BRICS data analytics course program. Okay, Arjun?
Yeah, so am I audible?
Can
Am
you
I
go ahead?
audible?
Yes.
Okay. Good morning, sir. Thank you very much for this amazing introduction. And my question is that the project that we will do in the last capstone project, the topic is chosen by us or it will be given by the team?
You mean the capstone project?
Yeah, like the project is chosen by us, the topic we have choose or you will give us the project topic.
So yeah, the project will be, the topic will be chosen by you. But it must be something, it must be a science case, may not necessarily be astronomy because we don't want to make it biased. For those who are familiar, for those who have background in astronomy, yes, you can proceed with doing something in astronomy. For those who already have background in other sciences, maybe you can proceed to pick out a data that you can analyze and do provide some insights. And all of this should be done in a Jupyter notebook. Start from beginning, your data sets, how to build in the data, clean the data, do some statistical analysis, and then as well as the visualization. This is the minimum that we expect from you. Yeah. So, but then you can do so. But unfortunately, if maybe you don't have any ideas, I think this is where people can also brainstorm in the community in the community to ask questions. But we'll look out for cases, or even in the astronomy case, when we get through the data week 4. When we get into data sources, I think that will be very useful because that is for those who do not have any problem that they have in mind. That will be that will be a week that you can easily pick out a data from any of the sources and think about how you can analyze it yourself and generate insight from it. It's just something basic. You don't need to stress over it. There's also Google. You can search for different data sources. Something that interests you. Let's start with something. What are the things that interest you, whether in astronomy or otherwise, that you can do? I think that will be more reasons for you to do it, because if you have an interest already, then it's a win. All right. We have Subagia.
Okay, thank you very much.
Welcome.
Hello,
Subagia.
sir. Yes, sir.
Yeah.
Sir, I have installed Jupyter notebook locally. Is there will be any problem if I install through Anaconda again?
So if you're able to install Jupyter Notebook locally, I believe, how did you install it?
By pip install process in
Yeah,
command prompt.
that's fine. You installed it I guess you installed it through maybe a virtual environment, right?
Yes, sir.
Good. You can work from there. That's brilliant. You can work from there. Then it means if you can install Jupyter Notebook yourself, it means at least you already have some background on how to do that. So you can work from there if you don't want to install Anaconda, because Anaconda is big. You can work from there. You know how to start the Jupyter Notebook from your terminal?
Yes, sir.
Good. Then you can start your server there and then open the Jupyter Notebooks, and the ones we're going to share in the folder that you want to open it from, and then you are good to go.
Okay, sir. Thank you, sir.
You're welcome. Okay. Mehu.
Sorry, that was by mistake. Sorry.
Okay. Are we done with the questions? Is there any other hand? Okay. So one more thing. I think I forgot this earlier, but let's do that now before I forget again. Back to the Slack channel, so I can see we have
Sorry, Daniel, there's one more question in the chat from Mahesh.
Okay.
Do we get that capable through this training program, like IDIA to solve the problems related to astrophysics?
There we go. do we get capable through the training program, like ideas to solve problems related to astrophysics? Of course. So starting from week 4, we'll be talking about different astronomical data sources and how to analyze astronomy data. We're going to do some of the basic ones. So with that, you can start. That is a good start for anything related to astrophysics. So expect that from week 4, but from week 1 to week 3, we're going to focus on the concept of programming itself and data analysis and visualization. So after that, before we jump into astrophysics. Remember, week 4 is astronomical data sources, how to analyze them, how to collect them, how to query them. Then week 5, we're going to touch on time series. And then week 6 and 7, we do machine learning. Okay, somebody is saying Anaconda Navigator is not responding on your PC. I guess maybe you have a low memory. You can close it and restart it again. Otherwise, you can use the Google Colab. If it fails, you can use the Google Colab. So I think someone asked questions earlier about the Jupyter notebook, running it locally. Was it Mehu? Also, I've forgotten. Please, you can also write that and share that information in the Slack community. For those who don't want to install Anaconda, you can also maybe write a short guideline to help those who may not have the resource to run Anaconda.
Sorry, on that matter, Daniel, I've just created a channel called Technical Help. So if anyone has questions concerning technical assistance that they need or can help others, feel free to post in that channel.
Yeah, good. So you had that. There's a technical channel there, assistant. Just go, if you have encounter any problem and you're able to solve it, you can share the information there. If you also have a problem, please make use of it. Okay, I'm seeing another question. We can do a capstone project related.
I have one more question, if I can.
Yeah, just a moment. Exi said we can do a capstone project related to non-astronomy data. Of course, you can. Like I said, it's all remember the skills we are learning from week 1 to week 4, even down to week. All of the weeks are relevant for you, are relevant for any science use case, for any problem, even business problems. So because data analysis is a skill that is applicable to every field. So long as there is data, it must be analyzed. So the only thing is if you have an interest there, and you know how to collect this data, and you know how to define a problem around it, then so be it. We don't have any issues with that. Okay, so back to Slack. I'm saying we have at least 80 people join the pre-orientation. Then the resources have been shared. Thank you, Sally. Been shared there, and okay, and then okay, so just to so just to give a hint on how to handle questions asked in the Slack channel. Let me increase this. I think so this is too small. Okay, let's speak now so people can see. All right, so let's take a look at this example. I can see someone said, can the links showed by the last slide for more tutorials be shared over here? Yes, of course. So let's say I want to address this very comment. This is applicable to everybody in this course. Please, this is what you need to do. Whenever you want to respond to a comment or a question raised by somebody, I recommend that you're going to see these buttons hovering around the question. This is just to mark it good, and these other ones are just emoji reactions. And this is how you need to respond. Please don't just go and type. Like if I want to respond to Rohit now, and then I come here and write, that is not recommended. So what is recommended is come here, over through this. So you see this reply in thread. That's the 5th icon. You click on it, and then in that case, it opens a new pane for you on the right for you to respond. Now, in this question says, can the links showed by the last slide for more tutorials to be shared here? I said yes. It will be shared. after the online meeting section. So you can see this is my respond, and you click this for it to send. Now I want you to notice something. Automatically, it shows one reply. If you want to also provide additional information, you can click on it and then you continue the conversation there. Because if you do not do that and then you come here directly and start responding, you are going to create a whole lot of disorder. Maybe somebody might ask question, and while you're also typing, another person will go and ask question, then you see a lot of disorderliness in the channel. So please, let's obey these rules, or let's stick to it. Also, when responding or while writing, Slack allows you to share code. This is a code. Let's say, for example, I want to write a code. I could, maybe you're having a problem. You encounter an error. You should be able to at least paste something that people can easily read. Let me create a scenario now. I'm not sure if I have a terminal open. Okay. So let me create a scenario. So now I have Python here. Let me say, I could write something, let's say, for example, like import the package that I'm not sure I have here now. So, okay, this is Anaconda itself, so it does have a lot of the packages. Okay, let me say I made a mistake. Let me say I do import NumPy. And so let me increase this. Let me see. Okay, and then I say MP.maths. That's me just creating something in my head. 2, 4, 5, 6, 7. Okay, it creates this. And then I say, let me say I do the same thing again, and I see what it can create. And then I do something like, so maybe I'm supposed to write mp.maths, MAT, and then maybe for whatever reason, I'm not that conscious and I made a mistake, and then I write mp.maths, MATH, the same line. So you can see it throws me a warning, and then it throws me an error. So this is a terminal. Don't worry, it's not going to look like this on your Jupyter Notebook. But in Jupyter Notebook, it's going to look a bit cleaner. So what you need to do is to copy. So I will advise what you do need to do is to copy the exact code that you have run and the error this way. If you copy it, you come to Slack, and then, so I can say, oh, let me just do a demonstration now. Okay, I need to remove this. Oh, I encountered an error. Then you click Shift Enter to go to the next line. Then this is if it's just one line code, you can use this. But if it's a block code like multiple lines, it's going to create this interface for you. Then you click Paste. Now, looking at this, you can see it looks cleaner. This looks very clean compared to when I paste this here, this way. I'm not able to move this slide up. But now, this is me writing the same code in the normal text pane. You can see it doesn't look neat. It will take time for people to really understand. But here, it creates a different Canva for it. It looks presentable. The same lines are well formatted. So whenever you have an error problem, code problem, please kindly paste it this way. And even when you are replying in a thread, like what I did here, you can do the same thing at the same time here. So that's one thing you need to have at the back of your mind. Yeah, so I'm not going to post this. I'm going to delete it. Yeah, so deleted it. Now, I'm seeing a question by Rohit here. He said, I'm looking for a PhD position. Is it helpful to get a PhD position? I think yes, of course, if you mean data analytics, whether this course is helpful, of course it is helpful, because if you do not have programming experience, then it's one of the key things to get a position to be in a PhD. Still in the scientific field, you need to have programming experience, and Python is one of them. And if you have a strong programming experience, at least you can get started in a PhD. But if you are looking, I think you can check out job register. I just go to Google and search job register, and then you're going to see a lot of, if it's astronomy anyway, you're going to see a lot of astronomy opportunities shared there for PhDs and above. So I think we've done this. We have, to an extent, I'm not sure there's any other question. Is there any other question? Okay. So
I have one question. Actually, I had installed Anaconda quite back. So do I need the current version?
Yes, of course you can. You don't need to. If you have installed Anaconda in the past, you don't need to reinstall it again.
So the version won't create any problem?
No. And you can open a Jupyter notebook with it, right?
Yeah, of course.
Oh, no problem. Yeah, you're very started. So please look out for those who are having challenges installing, and with that you can also help out based on your experience.
Okay, thank you.
Yeah. Cool. Okay.
Sorry, can you restate the slides finding astronomy opportunities again?
Okay. So on the opportunities again, I said job register. So this thing is okay. Let me see. What's this question? Can I apply? Yes, I should be able to apply. Okay. So it's job register. Just search it on Google. You're going to see AAS. I think it's AAS. Yeah. AAS.
Sorry, Daniel.
Yeah?
This is Sally again. Just to note, I've made on the Slack, there's now a new channel called Job Advertisements and Opportunities. So if anyone, I'm going to post this right now, the job register. If anyone has any other advertisements or PhD positions or anything throughout the world, feel free to post that on that Slack channel.
Good. All right. So I think that's it. We can end it here. So please, when you are done with your installation, the week 1 resources, you can already see it on GitHub. We also share it in the week 1 section. Please start going through it. You don't have to wait for us to get to the lecture. Start going through it because they're also explainable. You can also, like I said, do more reading online. Some additional resources are also shared in each of the notebooks. Please go through it. And one more thing, you can also create channels if you want for maybe countries. We have different countries. You can also create maybe say data analytics, your country, people can go there, interact, but please respect the channels, the core channels that we have, like the prioritization. Let it be anything around the orientation resources. And then for each of the course week, let it be things around the maybe problems or challenges you're having, or information about the week, course week. Yeah, that will help us to sanitize. Remember, you have a lot of people here. You want to make sure that even if people are not people, some people who couldn't join this online meeting, even if they are joining next week, they should be able to go through these channels and understand things without being confused. So please, you can create your own channel for Indians, South Africans, Egypt, anything, just so you guys can interact, learn in a group. You can also have your own meetings. So just go through each other, guide each other, and all that. So I do recommend that. So I think that's all. So Sally, do you have anything to say before we conclude?
Nothing from my side. Just so happy to have everyone on board, and I thoroughly encourage everyone to engage, ask questions, answer questions, and we look forward to seeing you over the next 2 months.
All right. So, okay. So guys, thanks again for joining this morning section. Please, we'll be looking out for your questions, and also please remember the rules, respect everybody. And don't be shy to ask questions. You're confused about any topic, Google is your friend. Bing is your friend. Even ChatGPT sometimes is your friend. You understand? So I believe if you combine all of these activities, you'll be able to learn better. And so that's it. So I think that's all. We can end this meeting and then see you guys next week. Bye, everyone.
Bye-bye.
Bye-bye.
Thank you very much.
Thank
Thank
you.
you very much.
Thank
Thank
you.
you very
Thank you.